Welcome student to Praveen Patil College of Diploma Engineering and Technology behind the East. Our department is Humanity and Science. Course Basic Mathematics, course code 22103. Myself again, Mrs. Smita Shekhar Kambale. Today's lecture is obviously depend on Unit 1, Chapter number 4, Partial Fraction. What is exactly we doing for the partial fraction? In today's lecture, we have to briefly check. Suppose 22 upon 35. Numerator number is what is? It is exactly smaller and denominator number is greater. That means it is the proper fraction. How? We know that if we have to split up these exactly 1 upon 5 plus 3 upon 7, if we take the cross multiplication, 7 into 1 7, 5 into 3 15, 5 into 7 35. So 7 plus 15 gives exactly 22 and 5 into 7 gives 35. So we have to split up these pattern into first factor plus divided by second factor. Now 57 plus 20. We have to convert this 57 upon 20 in this way. 2 plus 1 upon 4 plus 3 upon 5. If 4 or 5 means 20. 20 is LCM. So we have to multiply here 20 upon 20. Here we have to multiply 5 upon into 5. Here we have to multiply 4 upon 4. So equating with denominator we have 20, 20, 20. Here 20 plus 5 plus 12. It is exactly 57. So we have these 57 upon 20 is called improper fraction and 22 upon 35 is called proper fraction. So in these all the example now based on proper and improper fraction, always remind that the degree of numerator polynomial is less than the degree of denominator polynomial. That means it is called proper, and degree of numerator is greater than degree of denominator, that is called improper fraction. So I give the chapter 4 partial fraction mathematical definition. A fraction is a symbol indicating the division of integer. For example, 13 upon 9, 2 upon 3 are fractions. Obviously 13 upon 9 and 2 upon 3, these are non-zero numbers. It is invisible positive fractions and called common fraction. The dividend means upper number is called numerator, that is nx, and divisor lower number is called denominator, that is dx. From the previous study of elementary algebra, we have learned how the sum of different fractions can be found taking LCM and then add all the fractions. For example, we have to simplify 3x upon x minus 1 into x plus 2, 1 upon x minus 1 plus 2 upon x plus 2, 9x square plus 5x minus 3 upon x plus 1 bracket square into x minus 2, we can split up 2 upon x plus 1 plus 1 upon x plus 1 square plus 3 upon x minus 2. Here we study the reverse process, that is we split up the single fraction into number of fraction whose denominator are factors of denominator of that fraction, and these fractions are called partial fraction. So these pattern of right hand side are partial fraction. We have to convert it into single form of the fraction. That's why partial fraction can express a single rational fraction into the sum of two or more single rational fraction is called partial fraction resolution. Means example 2x square plus x square minus 1 upon x into x square minus 1. We know that x square minus split up into x plus 1 into x minus 1. That's why 1 upon x plus 1 upon x minus 1 minus 1 upon x plus 1. So here 2x plus x square minus 1 upon x under bracket x square minus 1 is resultant fraction, and 1 upon x plus 1 upon x minus 1 minus 1 upon x plus 1 are its partial fraction. Now we have to fix, that is left hand side it is in a form of numerator and denominator in a way of quadratic equation or factor. Then we have to convert these partial fraction into single fraction with numerator have a number and denominator have the factor and plus symbol is there middle between. Now we have to consult with polynomial also. Polynomial means the degree of the x variable in linear equation is greater than equal to 1. That means any expression of the form px is equal to an x raised to n plus an minus 1 x raised to n minus 1 plus a2x square plus a1x plus a0, where an minus 1 up to a2 a1 a0 are real numbers, that means coefficient of x. If an not equal to 0, then px is called polynomial of degree n. Rational functions, we know that p upon q, where q not equal to 0, is called a rational number. That means 13 upon 9, 2 upon 3. Similarly, the quotient of two polynomial, that is n of x upon d of x, nx is the polynomial have degree greater than 0, dx is the polynomial have degree x greater than 0. Be careful, dx not equal to 0 with no common factor is called rational fraction. A rational fraction is of these two ways. So, in this topic, we have to much clear about the mathematical concept behind the partial fraction. So, our actual process is start to solve the partial fraction. So, 5 types of partial fraction we have to discuss in partial fraction, how it is possible. Px plus q, x minus a into x minus b, then a upon x minus a plus capital B upon x minus b. We allocate the numbers, that is constant, as a and b always. Then we have to find the value of a and b. Compulsory a and b must be different numbers. That means a not equal to b. If px plus q upon x minus a bracket square, then we have to split up a up capital A upon x minus a plus capital B upon x minus a bracket square. That means we have to write x minus a raised to 1 plus b upon x minus a bracket raised to 2. If px square plus qx plus r means numerator have quadratic equation and denominator have three different factor x minus a, x minus b, x minus c, then we should write a upon x minus a plus capital B upon x minus b plus capital C upon x minus c. Next, if numerator have the quadratic equation px square plus qx plus r, denominator have the factor x minus a whole bracket square into x minus b, then we have to split up a upon x minus a, then plus b upon x minus a bracket square plus capital C upon x minus b. If the partial fraction in the form of px square plus qx plus r upon x minus a in bracket x square plus bx plus c, then capital A upon x minus a plus bx plus c upon x square plus bx plus c. Be sure x square plus bx plus c quadratic equation does not have factors, means ax square plus bx plus c not equal to 0. I repeat again. In first method, if px plus q is any factor upon x minus a into x minus b, these two are different factor, then we should write compulsory a capital A upon first factor of denominator plus capital B upon second factor of denominator. Be sure a not equal to b. Px plus q upon x minus a bracket square is there. That means repeated factor is there. Then capital A upon x minus a raised to 1. So obviously x minus a remain as the same. Plus capital B upon x minus a bracket square. Third one, px square plus qx plus r is there. Means any quadratic equation is given. and denominator have x minus a into x minus b into x minus c factors, then we should write capital A upon x minus a plus capital B upon x minus b plus capital C upon x minus c. Fourth one, if numerator have the equation quadratic form px square plus qx plus r, denominator have x minus a bracket square into x minus b, that means first factor is repeated and second factor is distinct, then we have to split up capital A upon x minus a first factor plus capital B upon x minus a bracket raised to 2 plus non-repeated factor c upon x minus b. If numerator have the quadratic equation px square plus qx plus r upon x minus a is the first factor, but second factor is a quadratic equation x square plus bx plus c. We consider that x square plus bx plus c not equal to 0, means this quadratic equation have no real factors, then it is applicable capital A upon x minus a plus capital bx plus c upon x square plus bx plus c. In all the lectures of partial fraction, you have to must know the fifth pattern of partial fraction format always and revise this one again and again. Let us try the example based on the first, that is 1 upon x plus 2 and sec into x minus 2, where plus 2 and minus 2 obviously have the different factor. So we have to take 1 upon x plus 2 into x minus 2. It is our partial fraction. So we have to convert it is in a partial fraction. Means capital A upon first factor x plus 2 plus capital B upon x minus 2. If we take the cross multiplication, that means x plus 2 and x minus 2 is the LCM. So here we have to take the x plus 2 and x minus 2, we have to multiply here. So x plus 2, x minus 2 get cancelled, 1 is remaining here. Then we have to take the cross multiplication capital A into x minus 2 plus capital B into x plus 2, x plus 2, x minus 2. These and these will get cancelled. We remain only 1 is equal to capital A in bracket x minus 2 plus capital B into bracket x plus 2. Now we have to substitute 0, means x minus 2 equal to 0, that means we have to put x equal to 2 in equation number 2. So 1 remain as the same, capital A remain as the same. 2 instead of x we have to put all the right hand side of this equation, that is 2 minus 2 plus capital B in bracket 2 plus 2. We know that 2 minus 2 is 0. 0 into anything remains 0. So we remain only capital B in bracket 4. So 1 is equal to 4b. That means b is equal to 1 upon 4. Now we have to consider the second factor. X plus 2 is there. So x plus 2 equal to 0. That means x equal to minus 2. So we have to put x minus 2 in this equation. So 1 remain as the same is equal to capital A in bracket instead of x we have to put minus 2 bracket complete plus capital B instead of x we have to put minus 2 plus 2 remain as the same. So minus 2 plus 2 gives value 0. 0 into anything is 0. So we remain that minus 2 is minus 4. That's why A minus 4 goes to this side. So we derive the final answer is A is equal to minus 1 upon 4. Now we resolve the 1 upon x plus 2 into x minus 2 is equal to 1 upon minus 1 upon 4 is the value of A and B value is 1 upon 4. In this equation we derive the final answer. So always remind that in a partial fraction if two factors are given we have to take the cross multiplication, then this denominator factor will cancel with this. A into x minus 2 plus b into x plus 2 is remaining. Then we have to put first factor x minus 2 is equal to 0. That means x equal to 2 in this whole equation. Then we have to put x minus 2 equal to 0. That means x equal to plus 2 in whole this equation. Then we have to derive the, if we put 2, we derive the value of b is equal to 1 upon 4. If we put x equal to minus 2, we derive the value of a is equal to minus 1 upon 4. So we have to put the value of a and b in above equation, we derive final answer.